Good afternoon, everyone. Welcome to Beyond 11 Nines of Durability, Data Protection with Amazon S3. My name is Yuri Zarubin. I'm a principal engineer at S3. And joining me on stage is Ankita Mishra. She works as a senior product manager alongside me at S3. Now, before we get started, I want to do a quick poll. Raise your hand if you own or manage an S3 bucket. Wow, OK. So just about everybody in this room. So this talk is specifically designed for you. As bucket owners, we have a responsibility to ensure that our data stays safe and secure. And that's exactly what we're going to learn about in today's session. So let's just quickly go over the agenda. We're going to start off with an overview of Amazon S3's durability culture. So we'll learn about what is durability, how do we think about durability. And we'll also learn about the architecture and mechanisms that S3 has which keep your data safe. Afterwards, we'll learn about the different threats that pose a risk to your data. And we'll learn how to mitigate these threats using S3 features. Let's get started. OK, so S3 promises you with 11 nines of durability. But how do we achieve this? Well, you might think it's the architecture, a bunch of fancy algorithms. And to be fair, we do have a few of those. But if you were to ask an experienced S3 engineer that's been a while what they thought, my guess is that they would say that it is the culture. It is the durability-oriented culture that we have cultivated over 17 years of service. And it is this culture that enables us to invent the algorithms and architectures that keep your data safe. The bar that we engineers have is to never lose a single byte. Now, that's a nice aspiration. But what we need are real mechanisms that ensure that we can do this consistently year after year, every single time. So let's take a look at one of these mechanisms. And we call it the durability review. Now, we borrowed this from security modeling, if you're familiar with that. And it goes something like this. Whenever you're authoring a change, you're making a change to the system. It could be anything. You could be fixing a bug. You're adding a new feature. You prepare a document that outlines a document called a durability document that outlines the threats to durability and mitigations. Then this document is reviewed by what we call durability bar raisers. These are seasoned S3 engineers that have expertise in durability. They make sure that teams think through the corner cases and have appropriate mitigation in place when it comes to durability. So all S3 engineers actually go through this process. And I can tell you from experience that I've personally spent countless of hours just sweating through the tiniest of details when it comes to durability, making sure that no stone is left unturned. And after years of everybody doing this over and over and over, what we end up is with a large engineering culture that's constantly thinking about durability. And I think that's the most important part. So let's take a look at some of the threats that a typical durability review would cover. OK, so starting off with storage device failure. This one's pretty common. We generally assume that hardware can fail at any time, and that we must ensure that we do not lose any data when that happens. To mitigate against this threat, we redundantly store your data across multiple devices. Now, there are several techniques to accomplish this. At S3, we use something called erasure coding. Now, this is where data is split into multiple shards. And so an example I got here is I've got shards A, B, C, D, and E. And they're represented by the different colors. And these different shards are then redundantly stored across multiple devices. Here, I've got 5 devices. And so if a device fails, we can, the data that it holds can be recovered from using the shards stored in the remaining devices quite easily. Let's take a look at another threat, data corruption. Now, there's a bunch of ways that this can happen. But what we've seen is there are these really rare hardware failures that can cause random bits to flip from 0 to 1 or vice versa. And this actually silently corrupts your data as it's being read or written. And it's actually really, really difficult to detect. And so the way we mitigate this is using end-to-end integrity checksums. Let's take a look at that in closer detail. So suppose you want to upload a file to S3. You'll use the AWS SDK or the CLI, and that thing will compute a checksum of your data before sending it to S3. S3 will then validate this checksum every step of the way as it passes through the system. We'll also compute additional checksums before we durably persist your data. Finally, we'll validate that the data that we stored is the exact same data that you uploaded. And only then will we give you back a 200 OK response, at which point you know that your data has been durably stored. Right? So there's no caching. Once you get that 200 OK, that means that your data is durable and safe. So as part of this durability review process, we mitigate durability threats that stem from facility failures, hardware failures, data corruption, bugs, deployment practices, and even operator error. We combat entropy so that you don't have to. Now, at this point, you might be thinking, OK, well, as a bucket owner, what do I need to think about? And the answer to that is human error. Let's face it, all of us make mistakes. What's important is that we have a way to recover from these mistakes once they inevitably happen. And broadly speaking, there's 2 ways for you to accidentally lose data. You can either accidentally delete it, or you can accidentally overwrite it. There's 2 mitigations for this that I want to talk about. The first is S3 versioning. This is a feature that enables you to track object changes. And the second is point-in-time backups. Let's first learn about versioning. So versioning is actually personally my favorite feature. And the reason for that is because it's super simple to configure. Just a single click in the console, and your bucket is instantly protected from accidental deletes and overwrites. Let's take a look at how it works. So once versioning is enabled, every object that you upload in your bucket will have a version ID. And multiple objects with the same name will form what we call a version stack. So if you made a mistake and you want to go back to a previous version, you can always do that. Deletes work differently in version buckets as well. Whenever you delete an object, we will create what is called a delete marker, and then we will put it on top of the version stack. And just like before, if you want to go back, you can always do that. Let's go through a few examples to kind of better understand how versioning works in practice. So just a quick recap of how S3 works. We've got a put command that lets you upload data to S3, which then creates the object. And we've got the get command that lets you read the contents and retrieve the object. So suppose you've got, in this case, what you're doing is you're uploading, suppose you're storing cat pictures in your bucket, and you're uploading a file called cat.jpg. So when you have versioning disabled, and you upload this object for a second time, the original object is overwritten. This can cause problems if this new write had the same name but different contents. So in this case, I mistakenly overwrote my object, my cat picture, with a picture of a dog. When you don't have versioning enabled, there is no way for you to recover from this, right? Because you overwrote your data, it's gone. There's no secret copy of it tucked away. Once you overwrite your data, you do not get it back. Let's take a look at deletes. Again, when you don't have versioning enabled and you issue a command to delete an object, that object is permanently deleted from the bucket, same as before. If you fetch it, you will get a 404 object not found because it's gone. Now let's take a look at what happens when you have versioning enabled, using the exact same example as before. When you upload the cat picture, it will now have a version ID assigned to it. In this case, the version ID is 1. When you get the object, the cat picture is returned, same as before. Now, if you write another file with the same name, instead of overwriting the object, a new version will be created. Now, the dog will be version 2. If you get this file, you will get the dog bag, same as before. However, since there's multiple versions of it, you can access that previous version using the version ID. So if you make a GET request where you specify the version ID 1, you get the cat back. Let's take a look at deletes. So by default, when you delete an object in a version-enabled bucket, the object is not permanently deleted. Instead, like I mentioned before, a delete marker is created on top of the version stack. Now, if you issue a GET request, you're going to get a 404 again, right? That makes sense because you just deleted it, and so it doesn't actually, well, it shouldn't theoretically exist. However, just like before, if you want to get the previous versions, you can always do that. If you issue a request with a version ID of 2, you will get the dog, and with a 1, you still get the cat back. Now, this is actually kind of cumbersome, right? Because most of our applications, when we create them, they don't really know anything about versions. They just know that there's an object, it either exists or it doesn't exist. And so in this case, what I've done is I've overrode my cat picture with a dog, and then I deleted it. And I actually just wanted to get it back, so my application is broken. So what I can do is I can delete the delete marker. I can just clear it. At this point, the current version, the latest version, is the dog. Then I can also permanently delete the picture of the dog, version 2. Now that's gone. Now my cat picture is the only version left in the version stack. And if I get it, my application now works correctly. OK, so to recap, versioning provides you with baseline protection against accidental deletes and overwrites. And versioning is actually what we call like a foundational feature. So a lot of the other data protection features that we offer are actually based on versioning. And we'll talk about those later. And we also consider versioning as a general best practice, like internally within AWS. So if any of the teams that wants to store data, they want to create a bucket, and they don't enable versioning, they will actually be notified internally asking them to enable versioning, right? So we use this feature heavily ourselves. Now let's talk about backup. Aside from versioning, sometimes you need something a bit more robust, and you do have the option to use a backup solution. These solutions will back up your data into a separate AWS account, and you can recover your data to a point in time. There's a few reasons why you may need to do this. Compliance is a pretty big one. If you're required to maintain a standalone copy of your data in a different account, then this is an option that you'll definitely want to explore. There's a lot of different backup and recovery solutions out there. I'm not going to go through these. But if you are interested, just head on down to the expo. Most of the names on this list will be down there, and they would love to talk to you. OK, so speaking of compliance, some of you may be required to maintain a standalone copy of your data in a different region, in a different geographic region, to hedge against the possibility of a widespread regional disruption. And there's two ways for you to mitigate this. The first is cross-region replication. The second is cross-region backup. Now, I've already spoken a bit about backup, so let's learn more about replication. So replication will always have a special place in my heart because I've spent the last 6 years building it from the ground up. And I'm super proud of the fact that we replicate over 100 petabytes every single week around the world. Replication is fully managed, so all you got to do is configure it and then let us engineers do the rest. And best of all, replication automatically scales with your business. We constantly monitor the size of your bucket, your throughput, and we ensure that you have enough bandwidth provisioned to replicate all of your data in a timely fashion. Now, replication has many features that satisfy a broad range of requirements. And I'm going to hand it over to Ankita, who is the product manager for replication, so I can think of no better person to walk us through this.
Thanks, Yuri. Hi, everyone. OK, so Yuri has already introduced S3 replication. Let's talk more about it. Amazon S3 replication is an elastic, fully managed feature to replicate new and existing objects between source and destination buckets. It offers the flexibility to replicate within the same AWS region with S3 same region replication, and you can choose to replicate to a different AWS region with S3 cross-region replication. You can also choose to replicate to a different storage class at the destination to optimize your storage costs. And with S3 replication, you can replicate objects that are encrypted with different encryption types, including SSEC, SSES3, and SSEKMS encryption types. S3 replication offers the functionality to replicate to a different AWS account at the destination for controlled data access. And you can also choose to replicate parallelly across multiple destinations. Finally, S3 replication offers reliability with metrics and events to track minute-by-minute progress, and with features such as S3 replication time control, which is backed by an SLA to replicate 99.9% of objects within 15 minutes of upload. What's really powerful is that you can mix and match these different features of S3 replication and customize each replication rule to suit your business needs. With that, let's dive deeper into the building blocks of S3 replication. To create a secondary copy of your objects or to start replicating data, you first need to configure a replication configuration on your source bucket. This configuration can apply to your entire S3 bucket, or you may choose to replicate selectively using prefixes and object tags. Each configuration can have multiple replication rules, and each rule can have different settings enabled, like replication metrics, delete marker replication, replication time control, and so on. Let's start by configuring a simple replication rule to replicate objects from US East 1 to US West 1. In our example, we see that we have an ID. We're calling it the data protection rule, and we also have a bucket arm. This is the bucket in our destination US West 1 region where objects will be replicated to. Now, this is a simple cross-region replication rule. Alternatively, we can have a similar rule for same region replication by using a bucket arm which is in the same region as the source bucket. Now, to optimize storage cost while ensuring cross-region data durability, you can choose to replicate to a different storage class at the destination. Since the data in our example is mainly for backup purposes and may need to be retrieved quickly in case of any disruption, we have chosen to replicate to S3's Glacier Instant Retrieval Storage class at the destination. In our example, we can see that under destination, our storage class has been updated to S3 Glacier Instant Retrieval. Alternatively, you can choose to replicate to S3 Standard, S3 Intelligent Tiering, S3 Glacier Deep Archive Storage class, among others, depending on the data access pattern at the destination. With that, we have our simple cross-region replication rule to replicate objects from our primary bucket in US East 1 to our backup bucket in US West 1. Now, this replication rule can be used to replicate all the new objects that are uploaded to our primary bucket. But what about your legacy objects? Objects that existed in your bucket before any replication configuration was created on it. Well, to replicate these objects, you can use S3 batch replication. S3 batch replication uses S3 batch operations job to replicate existing objects, re-replicate objects that have previously been replicated, or replicate objects that have previously failed to replicate. Here, I'd like to pause and address a very common question that we get from our customers, which is, in the rare case of a regional disruption, does S3 replication fail to replicate any objects? Let's see what the room thinks. Let's raise hands for people who think that S3 replication will fail to replicate objects in this case, if we lose any of our bucket by any chance. 1, any more? 2, 3. Okay, we have very informed audience. 4, okay. So the short answer to this question is no. S3 replication is actually designed to keep retrying replication of objects till it is successfully present at the destination. So in our example, by any chance, if we lose our bucket in US West 1, which is a very rare case, but if by any chance our US West 1 bucket, our destination bucket, becomes unreachable, in that case, S3 replication will continue to queue all the objects that are uploaded to our primary bucket and will continue to retry to replicate those till our destination bucket is back up again. No objects are lost or dropped in this process. Having said that, S3 replication can fail to replicate objects, yes. But that will only be the case if there are any configuration errors or inadequate permissions while configuring replication. For example, if your destination bucket name is incorrectly spelled when you're trying to configure your replication, or your destination bucket is deleted altogether by mistake. In that case, S3 trying to re-replicate objects will not be helpful, because here you will have to go back and update your configuration to fix these errors for replication to be successful. This is why S3 replication will fail to replicate objects in this case, and you can go back and fix these errors and re-replicate the failed objects using S3 batch replication. Now, to monitor if there are any failures while replicating objects or to track the progress of replication overall, S3 provides 4 detailed metrics. Let's talk about the first one, which is the replication latency metric. Now, this metric shows the number of seconds by which the destination bucket is behind the source bucket and can be very useful to refer to if you have recovery point objective or RPO requirements. Next, we have the bytes pending replication metric, which shows the number of bytes that are pending to replicate from source to destination for a given replication rule. Similarly, the operations pending replication metric shows the number of operations that are pending to replicate from source to destination. Finally, we have the operations failed replication metric, which we launched earlier this year. Now, this is a very useful metric because it shows the status of failures per minute for any replication rule. Now, again, failures can only occur during a replication if there are any configuration issues or inadequate permission. But when there are failures, then you can use this metric along with the S3 replication failure events to get insightful, actionable information, like the number of objects that are failing to replicate, which exact object key is failing to replicate, and most importantly, the reason for failure, which you need to fix before you re-replicate the objects using S3 batch replication. A quick note here is that the first 3 metrics, replication latency, bytes pending, and operations pending, can be used to track new object replication only, while the operations failed replication metric can track both new and existing object replication. You can turn these metrics on for any particular replication rule, and these metrics are available by default if you have S3 replication time control or S3 RTC feature enabled. Next, let's talk more about the S3 replication time control feature. This is a premium feature of S3 replication and can be very valuable for customers who have shorter recovery point objective or RPO requirements. S3 RTC comes with a predictable replication time and backs it up with an SLA to replicate 99.9% of objects within 15 minutes. By design, we actually replicate 99.9% of objects within 15 minutes of upload. And this is a very simple feature to turn on. If you are on your console, you can just turn it on with a single click. And when you do that, however, there are many systems and processes that are working underneath to make sure that you make the 15-minute RPO. This means that going back to our replication rule, which now has S3 RTC enabled, if for any reason we cannot access our data in the US East 1 bucket, in our primary bucket, at any point of time, our destination bucket, the backup data, will be maximum 15 minutes behind the primary, thus ensuring the shorter RPO. And this is not just a claim. we are actually confident about this, and that is why we back it up with an SLA. And not only that, we have 2 unique events to monitor adherence to this SLA. We first have the operations miss threshold event, which will send a notification every time any single object misses the 15-minute SLA. And we have another event, the operations replicated after threshold event, which sends another notification when that particular object successfully replicates to the destination. Overall, you can use S3 replication along with its different features like S3 replication metrics, S3 replication time control, to create a secondary copy of your data in the same or different AWS region or in the same and different AWS accounts to protect against any threat of regional disruption. With that, let's move on and talk about how you can protect your data on S3 from the threat of malicious actors. Now, these could be rogue employees who have authorization through access controls and IAM policies to access your data, but their intent is to do something malicious with that data. Now, to protect against these bad actors, you need to have additional control over your backup buckets, and you need some mechanism to keep your objects locked with strict limitation on who can access it and when. This is where S3 replication to a different AWS account and S3 object lock become very useful. Going back to our cross-region replication rule, for additional protection and controlled ownership of data, you can choose to replicate to a different AWS account at the destination. In our example, under destination, we see that there is a bucket ARN and there is an AWS account ID. This is the bucket in a different AWS account ID to which objects will be replicated to. Now, apart from replicating to a different AWS account, you can also choose to make your objects immutable by enabling S3 object lock. You can choose to enable S3 object lock on your destination bucket only to make sure that your backup data is impossible to delete, or you can enable it on both source and destination buckets. If you have S3 object lock enabled on your primary bucket, then you can easily create a replication configuration on that bucket to replicate these protected objects along with their retention metadata to an S3 object lock enabled bucket at the destination. Now, S3 object lock uses a write once, read many model to store your data. And you can easily enable it on your new and existing buckets for regulatory or compliance requirements. Cohasset Associates has actually assessed S3 object lock for environments subject to SEC 17A4, CFTC, and FINRA regulations. When you enable S3 object lock on your bucket, you have the option to choose a default bucket level retention setting, which will then be applied to all the new objects that are uploaded to your bucket, or you may choose to specify retention settings for particular object versions. You can also use S3 batch operations to specify retention settings for billions of objects using a single batch operations job. Now, S3 object lock actually provides 2 ways to manage object retention. You can choose to set up a retention period during which you specify a time period during which your objects remain locked. When you choose a retention period, you also have to choose a retention mode. You can choose to lock your objects using the governance mode. And if you do that, then no users can make any changes or delete your objects unless they have special permissions to bypass the governance retention. So if you choose to lock your objects using the governance mode, then you protect your objects from most users, but you can still give access to some trusted users to delete your data if it is required. However, if you choose to lock your objects using the compliance mode, then no users, including the root users in your AWS account, can make any changes or delete your objects. And this is why customers use compliance mode to lock their most critical objects, which they cannot afford to lose even if their administrative credentials are compromised. Now, apart from using a retention period, you can also place a legal hold on your objects. A legal hold does not come with a retention period, a protection period basically, but it continues to protect your objects unless it is explicitly removed from the object version. And users need to have the put object legal hold permission to put or remove legal hold from an object version. So by replicating objects to a different AWS account and by making them immutable by using S3 object lock along with its different features, you can protect your objects from any malicious overwrites and deletes. With that, we now have a multi-region storage solution which is resilient to accidental and malicious changes and any threat of regional disruption. But we still need a managed failover mechanism to ensure business continuity in case we actually need to fail over to this secondary copy of our data. And this is where S3 multi-region access points become very useful with their dynamic request routing to the lowest latency bucket and managed failover controls. S3 multi-region access point is actually a new type of global endpoint that sits in front of multiple S3 buckets in different AWS regions. This global endpoint is actually not associated with a particular AWS region, but with a single global host name that can be used to access any of these underlying buckets. Now, the underlying buckets in this case, these are no magic buckets. These could be your existing buckets, or you may choose to create new ones if you like. And if you have any replication configuration on these buckets, you can continue to use the same or create new replication rules to replicate your data. S3 replication actually works independently of this feature under the hood to keep your source and destination buckets in sync. But paired with S3 replication, S3 multi-region access points actually provide an advanced traffic management system for automated failover in case of any disruption. Using S3 multi-region access points actually vastly simplifies the creation and maintenance of multi-region storage solution by adding multiple buckets to a single global endpoint. It also helps to centrally configure your applications by routing requests to a single global host name instead of to specific AWS regions. And finally, it supports an active-passive configuration with customer-initiated failover, which lets you operate in an active-passive environment and initiate failover to a secondary AWS region within minutes. Recap, now we have spoken about different features of S3 that can help you protect your data. We spoke about S3 versioning, S3 replication, S3 object lock, and S3 multi-region access points. With so many different features, it can be difficult to visualize the protection level on your S3 buckets. And this is where we offer S3 Storage Lens. S3 Storage Lens is actually a storage analytics service that provides organization-wide visibility into your storage usage and activity. It comes with over 60 metrics in an interactive tool that can help you gauge any improvement opportunities around cost optimization, data protection, access patterns, and performance. Let's take a quick look at the various data protection metrics that are offered on S3 Storage Lens. And these include metrics for S3 versioning, S3 replication, S3 object lock, and encryption. On our screens, we see the default dashboard that comes with the free tier of S3 Storage Lens. Now, the metrics on this dashboard are based on 14 days of historical data. And as we can see, we have metrics showing the number and size of objects that have versioning enabled, number and size of objects that have object lock enabled, the percentage of replicated bytes at source, and so on. In addition to this, S3 Storage Lens also offers an advanced paid tier, and this advanced paid tier has metrics based on 5 months of historical data and gives you more actionable insights like the replication rule count for same region replication, cross-region replication, replication rule count for invalid buckets at the destination, and so on. But the important question here is, how does Storage Lens work with the existing data protection features on S3? And that is the cool thing here. All these features are layered smoothly on top of each other and work together to protect your data. And Storage Lens sits on top of this, and it can provide you a high-level view on an account level and an organization level to see the high-level protection for each of your buckets. And you can also drill down to get more information on a region, storage class, bucket, and prefix level. So with that, we are at the end of today's session and would like to conclude with some key takeaways. As Yuri mentioned, the architecture and culture of S3 make it a safe place to store your data. To protect against additional external threats, we offer features such as S3 versioning, S3 object lock, and S3 replication. To ensure business continuity with automated failover in case of any disruption, we have features like S3 multi-region access points. And finally, we have S3 Storage Lens, which can give you visibility into the data protection level of your individual S3 buckets. Thank you for attending today's session, and we are open for questions.